Okay, so today we'll solve GET 2020 question. This is a question from real analysis and question number 43. So it is saying that let p between 0 and 1 and x is all such continuous all such continuous functions such that integral of f to the mod f to the power p should be finite. And for f belongs to in this space, we define this. So basically this is type of norm, not exactly norm. Mod f suffix p integral of mod x to the power p dx to whole to the power 1 by p, because this is finite. It's we have for f belongs to s, so that's why we have defined like this. Then the four options are given. You have to check which one is correct so that it's defined a norm or satisfying triangle inequality or it will converge. So these are the four options we have to check. Okay, so this is the NPTEL reference for this question that you can also check. Okay, so let's start solving this one. So what is x? X is f r to r continuous and integral over r mod x to the power p dx. So this is finite. Then we have defined this f suffix p to be the integral of f mod of fx to the power p dx to the power 1 by p. Right, then we have to check that this is a norm or not, and the next inequality satisfies triangle inequality or not. So if you check b, then so first we will check b that it is true or not. So let's check first b. To check, oh, and one important here, p is between 0 to 1. So this is a one important fact where p lies, p in 0 to 1. Norm f plus g p less than fp plus gp. Right, so this we have to check where f and g are in x. So we'll show that this is not true. So this you can easily check for taking characteristic function, but note that here characteristic function is not in this class x. We have to take the continuous function. So we will modify this characteristic function a little bit to make it continuous and do this. So what is the idea? Let me tell. So suppose this is 0 and this is 1. So what we will do, and this is 1. So take a function like this. So we are basically exactly not taking the characteristic function and we make it it continuous. So characteristic function we will take then 0 to 1 only, but this is not continuous, so we will make this little bit modification to make it continuous. So this will take f, and otherwise it is 0, so it is only supported in 0 1, and take another function. So later I will take. So what is this? So this is our f. So what is the definition of f? Let me write. So this you can write also. So f is basically how it is defined. So it is 0 for x belongs to minus infinity to 0, and it is this linear function, right? Suppose let's also take this point to be, suppose it's 1 by 3, and let's take this is 2 by 3 where it is 1 in between. So on 0 to 1 by 3 it's a linear function, and at the point 1 by 3 it's take 1, so the function will be 3x, and at 0 it's 0, so x belongs to, so this is from 0 to 1 by 3, and now it is 1 for x belongs to 1 by 3 to 2 by 3. Then again it is a linear function, so it is at 2 by 3 it's 1, and at 1 it's 0, so it will take something like 3x by 2 minus 1 for x belongs to 2 by 3 to 1, and again after that we have defined it to be 0. So let me write it here, union 1 to infinity, and make it closed, because the endpoint it will agree the value, so it does not matter. So this is our definition of f. So we'll show that this inequality does not hold. We'll choose some particular f and g where it is not satisfied. So we have taken this to be f. So this is a continuous function. Note f is continuous. And how we'll take g? So g will basically take again the similar function, but just will shift by some number so that their support will be disjoint. So just shift it something like, suppose let's say x by x plus 5. We're shifting it right by 5. So how it will, so it is supported in 0 1, so it will be supported, and g will be supported on 5 to 6. So let's say this is 5 and this is 6. So it will take the value 1 here, so this is g. So g is basically shift of f by 5. Then g is also continuous. Now we have to check that these are belongs to this class x. So you have to check that this norm should be finite. Note that this is also note support of f. So where f is non-zero, it is basically this closed 0 1. So support of f is where the function is non-zero and closure. So support of f is 0 1, and support of g is closed 5 comma 6. So support of f intersection g is empty. And so what will be integration of over r fx to the power p dx. So this will be finite because continuous function and inside compact interval it is bounded function by 1. So this will give some finite value. So let's say this is this a. Define this to be a. So then so this will give some finite value, right? Then what will be integration of g? So this is just the translation of f, right, by 5. And if you, because Lebesgue measure is translation invariant, you can change the variable x goes to x minus 5, then you will get basically the integration of f, because this is same, just make the change of variable x goes to x minus 5. So this is again the a, so we'll get both integral of f and g to be a. So f is, we have shown f is continuous and both integral are finite, so f and g belongs to x. Now we have to check this one. So what is f plus g now? So f plus g, note that this is f plus g. What is f plus g? So it is 0, so it is fx whenever x belongs to support of f, means 0 to 1. For x belongs to 0 to 1, it will take only value g, it is gx when x belongs to support of g, because we have taken this to be a disjoint support, so that our calculation will be easier. So this is here, and otherwise 0. Right. So what will be this integral? Means what is this? F plus g to the power p. So this is by definition r f plus g x p dx 1 by p. So note that it is otherwise 0, so only integral survive when it is 0 to 1 and 5 to 6. And from 0 to 1 it will be fx, because g is 0 here, plus 5 to 6 it will be gx, because there f is 0. And what we have assumed that this integral, first integral, because this is f is only supported at 0, so basically this integral is 0 1, so this is 1. Let me write it. This is same as integral 0 to 1 fx to the power p dx, right? And this is again same as integration 5 to 6, because support of g is only 5 to 6. Right, so we'll get both to be this a plus and again this to be a, to be 1 by p. So it's 2a to the power 1 by p. So if integral f plus g, we have got 2a to the power 1 by p. And what is fp plus gp? So this is the integration r fx to the p dx to the power 1 by p plus integral r gx p dx to the power 1 by p. So the first one is a to the power p and second one is also a to the power p. So you have got this is 2a to the power p. But is this true? That is this satisfied? But note that, but note that for 0 less than p strictly less than 1, 2a to the power 1 by p is strictly less than 2a to the power 1 by p, as means taking the whole power of p, 2 to the power pa is less than 2a, right? So this is true because p is less than 1. So for p less than 1, this is true. So means what is 2a to the power 1 by p? So mod f to the power p plus mod gp is strictly less than mod f plus gp. So you have got this is true for all f. No, for this f we have got this one. So therefore this means, which is saying that this is not true for all f and g. So option B is false. So option B is false. Okay, so we have shown that this satisfies the reverse triangle inequality. Means mod f suffix p plus mod g suffix p is strictly less than mod of f plus g suffix p. So therefore option B is false. And what is option A? Option C is saying that this defines a norm. So option A also means option A is also not true. Not if this defines a norm on x, then this will satisfy triangle inequality. Must satisfy triangle inequality. But as this does not satisfy, so by option B, A is also not true. A is also not true because it does not satisfy triangle inequality. So option A and B is false. And what is option C? You have to check mod f plus g suffix p whole to the power p is less than equals to mod f suffix p to the power p plus mod g suffix p to the power p. So let's check option C. To check for fg next. So we'll satisfy this is true. So first we will prove this is one result. If p is between 0 and 1 and if s and t are bigger than 0, then s plus t all to the power p is less than s to the power p plus t to the power p. So we'll use this to prove this one. So first so this proof is easy. Proof, just let me say a few lines. So how to prove this one? So fix s positive, then you can, so f is a function from then close 0 infinity to r. So f is a function of t. You are viewing this as a function of t. Right. So that then f of 0 is 0. If you put 0, you will get 0. And for t strictly bigger than 0, calculate f dash t. What is f dash t? If you calculate, you will get basically t to the power p minus 1 minus s plus t to the power p minus 1. And this can be easily shown that this is bigger than 0, as since s plus t is bigger than t, which is 0, and As p is between 0 and 1, p minus 1 is strictly less than 0. So we have shown f0 equals to 0 and f dash t is bigger than equals to 0, means f is monotonically increasing and f0 is 0. So therefore, so ft is bigger than 0 for all t bigger than 0, right? So which means s to the power p plus t to the power p is bigger than s plus t to the power p. So this is the proof. So using this you can prove this one. So this is done. Now we have to prove this one. This should be less than mod f to the power p plus mod f, so to the power p. So this is by definition integral over r mod f plus gx to the power p dx. So now this we have used this one, that mod of f plus gx is less than mod fx plus mod gx. Use this one, so then what you will get, mod fx plus mod gx p dx. And by the above result, so this is s, this is t, so s is mod fx, t is mod gx, so then this will be less than mod fx to the power p dx plus mod gx to the power p dx by above result. So then this is the mod f p plus mod g suffix p. So we have got f plus g p, no, this is to the power p, this is less than mod f p p plus mod g p to the power p. So therefore this is true for all f g in x. So if you take the pth power, then it is satisfied triangle inequality, it is saying, right? And what is the, so this is option C is correct. And what is option D? It is saying that if fn converges to a pointwise on R, then this in this fn mod suffix p converges to f mod suffix p. So to check if fn converges to a pointwise, then limit n tends to infinity, means this is converges here. We'll show again that this is also not true. We'll show this is not true. So we'll give a counter example. So take this fn, sequence of function e to the power minus x minus n square. So then each fn belongs to not continuous and they are integrable also, that you can check. Note fn belongs to x for all n. And so where this will pointwise converge. So whenever if you fix some x and if you take n tends to infinity, so note that e to the power, so n x minus n, it will goes to 0. So for each x, for each x belongs to R, fnx converges to 0, right? So fn converges to 0 pointwise. Now you have to check that this converges in this is not norm, so there it will converges or not. So you have to calculate. So let's first calculate this one. What is this? So this is over r fnx to the power p dx. So what is fn? It is mod e to the power minus x minus n whole square p, and this is positive function, this is dx. Again n is here for fixed n, it is n is constant, right? So you can, and Lebesgue measure is translation invariant, you can make change of variable x goes to x plus n. So then it will be e to the power minus x square p dx, right? So what is this? So this is some for particular n equals to 0, right? So this is f0. So what is this? Is f0 p, right? Because this, suppose this is defined for all n bigger than equals to 0. And so f0 is basically e to the power, where f0x is e to the power minus x square, right? And note that this is continuous and pth integral function. So f0 is in x, and this is also positive, and this is strictly bigger than 0, right? Because this is positive function, as e to the power minus x square is strictly, so positive function if you integrate, and this is positive on a measure 0 side, so this is integral will be strictly bigger than 0. So this is, so what we have got, this norm is same as f0 p, and which is strictly bigger than 0 for all n. So can this converges to 0 function, because this is always bigger than, strictly bigger than 0 for all n. So therefore fnp does not converges to, so 0, it does not converges to 0 function, right? So it is converges pointwise but does not converges in this sense. So therefore option D is also false. So therefore which one is correct? We have got that option A is false, this does not define norm. Option B is also false, this does not satisfy triangle inequality. But it satisfies triangle inequality whenever there is a pth power. And the last one is also not true. So you have got option C is the correct. Okay.